Hi, I'm Welder Oliveira, a math and statistics tutor. Today we are going to talk about chain rule. First of all, let me highlight that this here is the tool that I use in my classes. With this tool I can draw graphics, I can draw formulas as well. You can interact with me here on the board. So if you are interested in my classes, you can contact me and we can schedule a classes for you on any calculus topics that you desire. So let's start. First of all, let's write here the expression of the chain rule. The chain rule is a rule for differentiation. So if you have an expression like this, f of g, and you want to differentiate this expression, you can apply the chain rule, which tells us that the derivative of a compound function, remember, chain rule is for compound functions. You use chain rule when you are facing differentiation in a compound function. So you have to identify two tractor here. You have to identify the outermost function. So you have here the outermost function, and you have here the innermost function. What the chain rule tells us is that the differentiation, the derivative of this expression is given by the derivative of the outermost function in the innermost function. You have to put the innermost function here, times the derivative of the innermost function. So this here is the formula, okay? So let's see some examples. So let's say that you have the expression sine of x plus x cubed square, and you desire to compute the derivative of this function. So first of all, you need to identify, let me change color here please. You have to identify what is the outermost function. So hit the outermost function is the function something square. So the function f of x equals to x squared. See, you have something square. So you have something square. So you have this function here for the outermost function. And in the innermost function, you have sine, the function g equals to sine of x plus x cubed. Okay, so let's remember what the chain rule tells us. The chain rule tells us that if you have f of g, the differentiation of this is the derivative of f computed in g times the derivative of g, the outermost times the innermost. Okay, so here you have to differentiate this f, which is, let's remember how can we differentiate a polynomial expression x to the n power for any value for any here. So the derivative of this expression is you can bring the n down here. You can bring it down, and you decrease 1 unit in the exponent. So applying this rule here, x squared, the derivative of x squared will be bring 2 down, decrease 1 unit here in the exponent. X to the to 1 is just x, so here is 2x, okay? But here in the formula for the chain rule, you have to compute the derivative of f not in x but in g of x. So let's do that. So let me erase this here, and let's continue. So here we have derivative of f computed in g will be, in this case g is this, so will be 2, just repeating here, 2 times x, but x when the argument is x. When the argument is g, it will be g, but g is sine of x plus x cubed, so here we have sine of x plus x cubed, okay? And let's continue here in this line. G prime will be the derivative of this sum. The derivative of a sum is the sum of the derivatives. This is a property of the differentiation. So the derivative of sine is cosine plus the derivative of this polynomial here. We have seen for x squared that what can we do here? Just bring the exponent down and decrease 1 unit in the exponent, okay? So this here is the g. Let's put all the pieces together and get our answer. Let me put this in white again. So the derivative of sine of x plus x cubed square is equals to, using the formula here, you need this quantity here that we have computed here, so is 2 times sine of x plus x cubed, okay, times g prime x, which is here, so times cosine of x plus 3x squared. Final answer, okay? This here is the answer for this differentiation. Now let's see another example. So now it's your time. See this function here, f of x equals to logarithm, natural logarithm of sine of x. Pause the video and try to solve this derivative. Okay, so let's solve it right now. The derivative of f, let's put here the formula of chain rule again. When we have f of g and we want to differentiate this expression, this will be the derivative of f, the outermost function, computed in the innermost function as an argument, times the derivative of the innermost function. This is the rule. So let's do it here. First, what is the outermost function in this case? In this case, the outermost function is ln. So you have ln of something. That is the outermost function. In this case, here you have some function that is not x inside it. Okay? And the innermost function is sine. Let's call this here, well, I will just let this way here and compute here the f prime of x is equals to, first, what is the derivative of the outermost function? Is 1, is the derivative of the logarithm. The derivative of the logarithm is 1 over its argument, but when the argument is x, in the denominator you put x, but you have to obey the rule of the chain rule. You have to compute the derivative not in x, but in g of x. In the innermost function, you have to put the innermost function inside the derivative of the outermost function. So here is 1 over something, which relates to this here, to this here, but in this case is sine of x, because this here is the innermost function, okay, times the derivative of the innermost function, the derivative of sine of x. The derivative of sine of x is just cosine of x. So this is equals to cosine times 1 divided by sine. Do you recognize this expression on the right side? This expression here? Do you have some nicer formula for it? Well, let's remember that tangent of x is sine of x divided by cosine of x. Okay, here is just the inverse. Can you see it? So this here is not the tangent, this here is the inverse of it. This here is the cotangent, the cotangent of x. So final answer, cotangent of x. The derivative of f is just cotangent of x, which is a nice result because here you have a logarithm combined with a trigonometric function, and the derivative of this is another trigonometric function, which in first place seem not to relate to the logarithm. This is a very strange result and nice result for this reason. So that was the classes that the show that I was planning for you today. And if you intend to take a online class with me, you can see the information on the description of the video, and we can cover any calculus topics that you desire, and hope see you next time.